All right. Uh, I wanted to go back to lists for a little while and work with lists some more because lists are going to be such a primary part of a lot of the development that you would do in Python, and knowing how to manipulate them and how to work with them is really important. So let's make ourselves a list. I'll pause here for a second, see if you can remember how to make yourself a list. Let's call it nums and make a list of integers. I'll give you a moment to see if you can figure that out. All right. If you pause the video, you can pause the video if you want to, but I'm going to go ahead. We're going to have nums equals 5, 6, 7, 8, something like that. And now we have a list of integers. The first thing I want to show you is how we might cut this list up. We might not want all elements in this list. So let's print a couple of different slices, we would call this, of this list. So first, let's print the first two, meaning we want all of, we're going to use this colon here, and we're essentially saying we want all of the numbers from the beginning to 2. Let's see what that gives us. I had been running my loops py, so now I want to write Python 3 lists.py. And you'll see I have 5 and 6. So let's talk through the logic of what's happening here. When we put nothing, our program will automatically assume the beginning of the list. This is going to be identical to if I had put 0 there, okay? But for shorthand, we don't have to put anything. The 2 refers to the index of the value that would be right after the last value you want to print. Because remember, in Python, lists are not inclusive of that end value. So it's including index 0, it's including index 1, and then it's stopping before it's getting to index 2, as we have 2 listed here. If we instead change this to be 3, we should get 5, 6, and 7 printed out. Okay? So again, from the beginning, 2, 5, 6, 7. Let's say instead we wanted to do the third all the way to the end of the list. We could do the same thing by leaving off the value of the end of the list and just putting in the first index of the number we want. And in this case, it's only going to give us 8 because 8 is at index 3 already. Let's say we wanted to start instead from index 1, and remembering that it is inclusive of that value, of that first value in our range. So it is going to take the 6, which is at index 1, the 7, which is at index 2, the 8, which is at index 3, print those out, and then stop because we've sliced it from the first one all the way to the last one. We can actually enter one more thing in here, one more value if we want, and that's what kind of steps we want to take. If we want to iterate by steps of 2, we can enter a 2 in here. Let me put another colon. And what this should do is iterate from the index 1 to the end of our list by 2s. So it goes 6, skips over 7, goes to 8. And if we had other things in our list, like 9, we could see what would happen here. It actually doesn't print the 9. Why? Because the 9 would not be included in that skipping by 2. However, if we had yet another value, like 10, we would now get 6, 8, 10, because we're going by 2s, right? 6, not 7, 8, not 9, 10. And so the 3 values here, when we're slicing a list, go start, stop. Remember, stop is non-inclusive, or I should say exclusive would be better to say what I'm trying to say. And then iterator or steps is probably an easier way to think about it, right? So the values are the start point, the stop point, and the steps you want to take when you want to slice up a list, when you want to take things out of a list. Which can be valuable in different, imagine for a moment we had 1, 2, 3, 4. We had this list of all the integers to 10, and I just wanted the even ones. I could, theoretically, starting at 0, and this gives me the odd ones, or instead, let's see, starting at 1, I could get all the even integers, right? So there are a few uses for this kind of slicing up of a list and grabbing particular parts that you want. You may even just want the just the first few of a list, and you could do it like that. Okay. Okay, so that's slicing up of a list. We can also, this is valuable too. If we want, we can move backwards through a list. And you'll see here we actually get 10, 8, 6, 4, 2, because what this now does is it starts at the end of the list and moves backwards because we've entered this number here. We could also do -1. We could say 0. So this is actually going to move starting at the 0th one backwards. The problem is the 0th one is already the end of going backwards. So when we think about our start and our stop going backwards, we actually want to kind of reverse these, right? This second one is now going to be the lesser of the two. That way we can go backwards. Remembering too that it's non-inclusive, right? So that's something to consider when you're talking about the start and the stop. The stop is never inclusive. It's always exclusive of that value. So in this case, it's actually not going to print the 0 value, but if we leave it blank, it'll go through the whole thing. You might think, well, what if I put -1 here? Well, let's test it and see what happens. We don't get anything because -1 is not an index in here, so it actually causes this just to fail. Leaving it blank is really the best way to get the full list going down from the top to the bottom. Okay, so that's how we slice. You've seen me use this function too before a lot, and I want to show it to you. It's the length function. If you ever want to know how long a list is, use the len or length method. This will tell you how many elements are in the list. In this case, there are 10 elements in the list, right? We knew that. But that's a really good and helpful function, especially if we're setting up for a for loop of something and we didn't want to do like the membership. We didn't want to do it for each thing inside there, but we wanted to use the length as part of a range. len is the way to get access to that for that loop. Okay, we can add things to a list. So there are a couple of ways of adding things. If we don't have a specific place for it to go, we just want to tap it on to the end. We can use the append function. Let me move those statements so we can see the result of our appending. So you'll see that we have our beginning list to be 1 through 10, and we're appending 11, and 11 should append right to the end of the list, which you'll see 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So it did append to the end of the list. I'll do this so it's not going backwards anymore, and we can see it going forwards in the right format. And now we have 11 things in our list because we've appended it. Appended is always going to add it to the end. Let's say for a moment though we didn't want to put it on the end. We wanted to put it somewhere else in the list. We could do insert. Insert is actually going to take two values. It's going to take the index where you want to put it and what you want to put in there. In our case, we're going to put 0 at the 0th place. So then if we run this, we now have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which is 12 values. And we don't have to insert at 0. We could theoretically insert at the 5th place, the 5th index. So now we have 1, 2, 3, 4, 5, 0, because that's the 5th index. And now we have 12 values again. So you can insert anywhere you want in a list. The first value in that is always going to be the index at which you want to do the inserting, and the second is going to be the value you want to insert. If these were strings, we would want to be inserting a string into that array instead, and it would work the same way, but instead of 0, you'd put some literal string. There are a couple ways of removing an item from a list. The first one is to pop the item. Pop takes the last item off the list. So append puts an item on the end of the list. Pop takes the last item off the list. And you'll notice when I print it, I'm popping the 11 off the list here, and now we're back down to 11 items, and you'll notice 11's no longer there. To remove the confusion, let me go ahead and put the 0 back in the 0th place just so things are in the proper place. Let's run this again. You'll see I'm still popping the 11 off. Pop, much like append, will only ever apply to the end. It'll not apply to any other place. However, we can also remove elements from a list. And with remove, you're just going to put the element you want to remove from the list. And I've wrapped this in a print statement to show you that we're going to get a none. And what none means is that nums.remove does not return a value. It doesn't give us a value back like pop does. It just changes the list. And if you look when we do our printing, our list has in fact changed. So this is changing. Remove is actually changing the list in place. Not unlike insert and append. Pop is changing the list in place, but it is also returning a value. So it's doing two things. It takes the last element off and hands it back to you so that you could assign it to a variable or something if you wanted to. Remove 5 just takes it out of the list. And if there were multiple 5s in our list, if we wanted to instead insert 5 at index 5, our list is 11 long after we pop off that 11 value. But it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have a 10. Oh, that's interesting. Wait. I think it actually remove might just remove the lowest of them, which I thought it removed all of them, but maybe not. No, okay, so remove is just going to remove the first of those values that comes along. It also might not find the value. So remove is a really good example of where you might want to use the try except structure because it could return an error. Let's say we told it we told it to return remove a 12. Let's just see what happens. And you'll see we actually get our script crashes, right? We get an error because 12 is not in the list, so we can't remove it. So remove is a good place to put your try except structure to avoid those mistakes. Okay, we can also work with our numerical data a little bit. I'm going to take out all these. We'll go back to our normal list of 1 through 10. And I want to show you a couple other functions that a list has that are nice, particularly when they're numeric. We can find the max value. Oh, sorry. No, it's not nums max. It's max wrapping nums like this. We can find the minimum of nums. And we can find the sum of nums. 10 is the greatest number, 1 is the minimum, 55 is the sum of the numbers. Okay, so some really nice ways of getting information, data, if you will, from a list like this by using some simple functions like max, min, and sum. We can also sort our list. So let's unsort our list. I wonder, let's see, nums.shuffle. I'm going to play just for a second. I want to see, let's import random. Yep. And then let's do random.shuffle, passing it nums, print nums. Let's see if this, okay, good. So I imported the random library because I wanted access to some randomizing code that I knew existed. In the random library, there is a function called shuffle, which will take a collection of items and essentially mix them up. And it will do it in place. So it takes nums, it shuffles it, and saves it back into that same space in memory of nums. And then when we print out nums, you'll see it's no longer in the same order. And if I'm not mistaken, Yeah, it'll change every time unless we set a random seed, which I'm not going to go into right now, but essentially it'll shuffle it every time if we want. And I do this so that we can see what it would look like if we sorted it. And there are two ways of sorting. We can do nums.sort. And what nums.sort is going to do, so let's go ahead and print nums after here. And you'll notice it will, so shuffle nums and then sort in place, returned nums to its sorted state. So nums.sort does that. And by the way, if I try to print this function call, this method call here, you'd see none because this is doing it in place. Remember the same way that remove did it in place? Sort does it in place, meaning it's changing the original value and returning nothing. Now, what we can do instead is use a function called sorted, which is not unlike shuffle. Pass it nums. And now let's see what happens. So it shuffles. We called the sorted, but then it still looks shuffled. Why does it still look shuffled? Because sorted is not doing it in place. Sorted doesn't actually affect the array nums. What it does is returns, so hands back to you, a sorted version of nums without affecting nums itself. So you'll notice when we shuffle, then we print out nums, we get the shuffled array here first. Then we print out the result of calling the sorted function, which is giving us a sorted array and handing it back to us. But then we print out nums again to show that it didn't do it in place. It didn't actually affect nums itself the way that shuffle did or sort does, but it sorts it for us and hands it back separately so that if we wanted to, we could make a new variable called sorted nums and print that compared to nums. So shuffles it, sorted hands it back in a sorted fashion. We print that out, but the shuffled one still remains. So that's just a nice way. Sorted will allow you to not change the original, especially if you can't change the original. If you're using something that's not, for whatever reason, mutable, you can still do sorted. Sort will change the original, right? Will affect the original. So that's something to do. It does it in place. Okay, one other thing I want to check is if a list is empty, because an empty list can cause problems. And let's see, maybe we can see some problems here. What happens if we call this stuff on an empty list? Okay, we just get empty lists. That's fine. But there are other things like that would cause errors. I think pop. Let's see if pop. Nums.pop. And let's go ahead and print the result of this. Let's just see what kind of thing we get here. Yep, and there's our error. Why? We can't do it pop because the list is empty, right? Index error popping from an empty list. So it's valuable sometimes to be able to test if something is empty. And we can do that by using our not operator and using our conditional. So if we said if not nums, print empty list, else pop something off. So now it's going to test and see, okay, is the list empty? It is, so we're going to print empty list. However, if the list weren't empty, we could pop 5 off of it and we wouldn't print empty list. So that's a good way of checking to basically see, is the list empty? You could also do if length of nums equals 0. It's another way. Or if nums equal empty list, right? Any of those checks would be fine for checking for an empty list, but it's good to know a few ways of checking for an empty list because, again, empty lists can cause us problems. Okay, that's all. One other thing that might be interesting connecting to our last lesson is using while loops with lists. So we've talked about for loops are a really good thing when you have a collection like this, but I could show you how we might use while loops. Let's give ourselves a few values, and let's do this. While nums nums dot pop, and we'll print it. We'll print what we pop off, and then print no more numbers. Okay, so you'll probably recognize some of the construction here, right? We're using our while loop. We're using while nums, which is closely related to the if not nums that we just did. We're basically saying while nums is not empty, right? Do this and then finish the loop. Let's see what happens. We get 5, 1, 5, and then we get it to print no more numbers. So while the nums is not empty, pop things off. When it's popped everything off, it finishes the loop because nums is now empty, and it will print no more numbers. So that's a combination of using our lists, using our pop function, and using our while loops. Okay.